Determine if the following integral converges or diverges. If it converges, determine its value. So we got an integral of 1 over 6 minus 9x from negative infinity through 0. Okay, this is very large, this is infinite. So this type of improper integrals are sometimes called type 1 because the limit we are working on is very large. So we cannot work on this very large, so we can make it kind of finite. Okay, it's a negative number, so this limit, this integral can be written in the following. Okay, so we can write limit, we can make this, let's say t, obviously negative, this number t through 0, and we let t go to negative infinity. Okay, so this definite integral limit is same thing now, 1 over 6 minus 9x. Now we want to integrate, evaluate upper limit minus lower limit, then later we take this limit. Now this one is a fraction, and let me remind you of something. When we have 1 over x, the derivative of bottom is top, that means natural log of x, so antiderivative of this. So if we have something like, let's say 3x dx and 1, if we think derivative, if we find derivative of 3x, that's 3. So we have to have 3 so that we can apply this rule. Okay, but for this question we could have just taken 3 out, but let's say 3x plus 1, then we cannot take 3 factor out all the way because 3 is not factor of both terms. So in this case, what we can do, just to use this formula, the function, its derivative on the top. So derivative of 3x plus 1 is 3. So we can simply multiply by 3. Then this 3 we can balance, we can cancel by multiplying by 1/3. So 1 times 3 is pretty much 3. And we can always take constant outside. So we can do this. Now 1 times 3 is 3. The top is derivative of bottom. That means this 1/3 outside. That means antiderivative is natural log of bottom. Okay, this is pretty much doing u substitution, but not showing all the details. So in general, if you have a function on the bottom and its derivative on the top, and you want to integrate, that is natural log of bottom. And we can always manage constants, because constants can be pulled outside, inside, not the variables though. So we have kind of the same situation here. 6 minus 9x, its derivative is negative 9. So I want to multiply top by negative 9, and to balance that I can divide by negative 9. So let me rewrite this. So this is limit t going to infinity of, let me put some room here, t to 0, 6 minus 9x, its derivative is negative 9, so I want to multiply top by negative 9, but negative 9 was not there. To cancel negative 9, we can divide by negative 9. Divide means multiply by 1 over negative 9 times. In fact, this can be pulled all the way outside. Now this is exactly like what we talked here. The top is derivative of bottom. So this one, I can pull this 1 over negative 9 means negative 1 over 9 all the way outside, and limit t going to, okay, this is negative infinity of, now let's find antiderivative of this, which is natural log of bottom, 6 minus 9x, and we want to evaluate this from t to 0. Replace x by 0, then minus, replace x by t. Okay, so let's see, this is negative 1 over 9, limit t going to infinity of natural log of 6 minus 9 times 0. 6 minus 0 is 6, and absolute value of 6 is 6, so just natural log of 6. which is a decimal number. That's the upper limit, minus lower limit, natural log of 6 minus 9t. Okay, now we want to take the limit. Again, t is going to negative infinity. I forgot to write, this is negative infinity. Okay, so when we take this limit, there is no t, so we have to work on this. So let's look at when t is very, very, very big but negative number, negative infinity. What's going to happen? Let's see this. So if we put L, t equals negative infinity, so this is going to be 6 minus 9 times negative infinity. So very, very big, multiply with 9. And this negative infinity, and negative means positive. 9 times very big is very big. Okay, you can think like 1 trillion something. Negative 1 trillion multiply with 9. It's going to be this negative, negative means plus. It's still very big. And 6 plus big is still big. So this is natural log of very, very big. And natural log of very big is very big. Okay, now in the limit sense, because we cannot work on infinity, but in the limit sense, natural log of very, very big is very big. Because if you graph natural log, this is the graph. So when t goes to very, very big, or x goes to very, very big, this one slowly increases but goes to infinity. So when t goes to negative infinity, by the way, this thing goes to infinity. We just do that. So it's a negative infinity. Oh, so whenever we have negative infinity or positive infinity, that means we don't have a finite number. That means the integral diverges. Implies, because this one is now, it's going to be some number, because of this infinity, the integral diverges. Diverges means the value will be infinite. We don't have an exact value, so we don't know. Diverges.